Welcome. In this video, I'm going to talk about a continuation of what I left in the previous video, which is types of mixtures. And in the previous video, I defined a mixture as consisting of two or more substances put together, but the individual components forming the mixture still holds their chemical and physical properties. And in our previous video, we talked about solid-solid mixture. And in this video, I'm going to talk about solid-liquid mixtures. And in solid-liquid mixtures, I'm majorly going to talk about solid, liquid mixture. Now, there are two types of solid liquid mixtures. The first one being soluble solid liquid mixture, and the second one being insoluble solid liquid mixtures. Soluble has one of its components forming the mixture capable of dissolving in water. Dissolves in water. Insoluble, one of the components, which is majorly the solid, does not dissolve in water, or majorly the liquid, to be precise. Now, when handling soluble solid liquid mixture, there are two important things that a student should note. One, there are instances when we are interested in both the solid and the liquid. But majorly, the liquids are always ignored because we find that water is always available. So most of the time, the liquid part of the mixture is not majorly discussed, but we always discussed how we can retrieve back our solid solid liquid mixtures. So imagine a situation whereby I'm having my salt, which is sodium chloride, and it is mixed with water. In most cases, people always tend to give a lot of weight to how we can retrieve the salt part, but people tend to ignore how we can get water. But in this video, I'm going to talk about both. If, for instance, I'm having a beaker containing salt solution, and I'm asked how I can retrieve the salt and also the liquid part of that given mixture, meaning I'm interested in the water that was used to dissolve the salt. Majorly, salt We always see, if, for example, the one we use at home, salt is always in crystal form. Crystal form. Now, there are two major techniques I can use. Techniques. The techniques I can use are two. One, I can use crystallization. And secondly, the second technique I can use is simple distillation. Simple distillation. Now, I want to explain how I can use both. In crystallization, I'm going to take my mixture. I'm going to take my mixture, which was salt solution, and I'm going to subject this to crystallization. And my crystallization is going to be a system that is organized this way. A system that is organized this way. A system that is organized like this. Then I'm going to pour my mixture. Sorry, my pen is misbehaving. I'm going to pour it into. So this is where I'm going to have my salt solution now. And I want to use a different color to label whatever thing that is going on here. This is my tripod stand. This is my evaporating dish. Evaporating dish. This is a wire gauge. Wire gauge for even distribution of heat. Then I have my source of heat given down there, which is majorly in the lab we have Bunsen burner. Bunsen burner, majorly. So when you organize your system like this, an experiment that is organized this way, sometimes an examiner can ask you to explain the procedure used during crystallization. And I'm going to do that. One, we are supposed to take the salt solution, pour it into an evaporating dish that is mounted on a tripod stand, and heat. Heat the mixture using Bunsen burner. Number two, so sometimes before I move to number two, let me explain something. Yeah, before I forget, let me explain something. That instances can come when you are asked to explain why we heat. Why do we refer to crystallization as heating instead of evaporation? Evaporation and heating always mean the same thing, but it's critically different in a way. The reason as to why we heat the mixture, we heat the mixture to remove to evaporate or to remove excess water. And if so, why? To make the solution, the salt solution for this matter, more concentrated. Now, someone might ask me, what is a concentrated solution? NB. A concentrated solution is a solution that has dissolved excess soluble solid. Soluble solid, sorry, excess soluble solid until it can no longer dissolve more at any given temperature. Now, that water, the fact that our procedure one, we are supposed to heat the mixture using a Bunsen burner. Then I've told you that we heat to remove excess water. Secondly, to make the salt solution more concentrated. And I've defined a concentrated solution as that solution that has dissolved excess soluble solid until it can no longer dissolve more of it at any given temperature. Meaning, even if you raise the temperature, no more solid will dissolve in that given solution. So that's a concentrated solution. So you have to know that it is a concentrated solution. It's a concentrated solution that forms crystals when cooled. When cooled. Those are things that you should know as a student. Now, I'm going back to my step 2. I've explained various things as far as our procedure 1 is concerned. Now, step 2, what are we supposed to do again? During heating, dip a glass rod into the boiling solution. Remove the rod and leave it to cool in air. This will help us know if crystals have begun forming. Now, there are two instances here when that occurs. Imagine a situation whereby we've dipped the glass rod into the boiling solution, we've removed it, left it to cool in air, and one, no crystals have formed on the glass rod. What do we do? Continue heating the solution. Continue heating the salt solution for this matter. But if crystals form, on the glass rod, then what happens? Stop heating and allow the concentrated solution to cool. To cool. Now, step 3. As the solution cools, crystals will form. So what do we do? Decant or pour out. Decant, stroke pour out excess solution. Next, if we remain with the crystals, dry them and keep them safe in the lab. That's how that's the explanation of what is happening here in this whole thing. So as we continue heating, you'll realize that it will be evaporating. It will be evaporating as we continue heating. So what is evaporating is excess water. It is excess water that is evaporating because we formed salt solution by dissolving salt in water. So it is excess water that is evaporating. Excess water. So the key reason as to why we are doing this is to make water concentrated. Concentrated. And it is a concentrated solution that will begin forming crystals. This is the whole procedure involved in the crystallization. That's the whole thing that is involved in the crystallization. Thank you very much. In my next video, I'll be explaining the second technique we can use to separate soluble, solid, liquid mixtures.